Hello, everyone, and I hope you are doing well and safe. We continue with the material, but before that, uh, I have to talk about the assignment that I gave you last time. I think it's about due maybe on Thursday. Uh, I think it's due on Thursday. So if we look here and we go to that assignment, uh, ARM instruction set, it says, where are you? This is risk 5 that we will be doing later. This I added today, and in the assignment, I think it's assignment 4, write a paper on ARM instruction set. Don't copy paste whatever you find on the internet. Write about the ideas that you, in your own language. Question from your paper will be on the exam. Okay, what to expect, guys? What to expect from that paper? You see, when we went through the PDP-8 instruction set, and we decided, or we saw in there exactly what we have. Where shall I go to show you? But PDP-8, you remember that instruction. And we counted the instruction, and we saw that if it's 110, then we go all the way back to the last 13. This is the design of the instruction set. So what we did here is I gave you the ARM instruction set, which is the power computer instruction set. This is RISC instruction set, by the way. And I said, write a paper on it. What am I expecting from that papers? To explain all those registers, those condition codes, those opcodes, how do RISC interpret them. Come on, you don't dwell on those. You can write a book on this. There are books on ARM instruction set. But I want you to be aware of those terms that's being introduced, registers, opcodes. On each part, understand each instruction and the fields that are on those instructions. I'm gonna do something today about the register set in Pentium computers. And also, when you submit this paper, I will ask you about, also, let me show you, this is not how I wanted to start, but because I'm answering the question on that. You see, this is what I introduced first. This is in your book, William Stalling, and I mean the slides part. These are not the slides part. This is elaborating on the register set. You see every register, what is it doing, and you see something like this. So this is explaining the register set that is found in William Stalling PowerPoints. Tamam? Now, the slide of the PDP-8, I explained myself. I didn't put a document that explains it. Look at this, guys, now. This one. This is the ARM instruction set, registers. So whatever I am doing in here, in the next assignment, you will be doing something similar to the ARM register set. So I gave you PDP-8 instruction set, and I explained it in recordings. You can go back and see how I explained it. And at the bottom of the handout, there were each opcode or condition code. What does it test? What does it do? Today, I'm going to explain a register set of sys computers represented by Pentium, and I want you to do the same for the register set of ARM, which is a RISC computer. So it's a matching between what I say in my lectures on sys computers, and you do the same similar work on the RISC computers.
Doctor,
Further.
it's for the 32-bit, 64 or 16-bit version of it.
The assignment or
Yeah.
okay. You see, doesn't matter. Wherever you feel comfortable, you see, they are the same. هلا مثلا, let me tell you something from now. A 386 computer and 486 computer are almost the same, guys. The set of registers don't differ, but look, I prepared this for you. Look. 486, I'm answering Levon, and I am starting the lecture anyways. لأنه this is what I'm gonna go through plus other things. 8486 processor features the 32-bit register set largely compatible with, you see, largely compatible with 8386. So this is 32-bit computer and 64-bit computers, and they are almost the same. So actually, if you learn ARM on 32-bit computers or ARM on 486 on 64-bit computers, I'll be happy that you know the essentials of what we mean by instruction set of RISC and CISC. So you choose, and I don't mind. But what I want you to do, guys, is that whatever you write on your paper, you understand. Yani you don't say any word in there as copy-paste without being able to answer the question. Eliminate anything that you don't understand. Let me show you what exactly should be answering in that paper. And we'll come back to this later on today. Let me see. Where are we now? Let me show you. Come on. So this is the downloads. And this is chapter 11, مش 12, لأنه assignment come from chapter. Let me go in. Wait a minute. What did I click? This sounds, yeah, wait. Addressing modes. Affected memory size here. Register mode. Here. Instruction, we are talking about instruction, Sheikh. Yani ARM, when we say machine, 32-bit machine or 64-bit machine, word, then what are we talking about? The memories are that it can handle, the memory organization, the bus structure, the complexity, the speed, and here, number of addressing modes. This is important, guys. This is what I want you at least to fill in your paper. You might get it from this paper and that paper, from this site and that from that site, from ChatGPT, one word from this. طبعا you write your sources at the end, just like I did with this document that I have ready. I'll show it to you when time comes. So number of operands, register versus memory, number of register set. How many? There are 32 registers. There are 128 registers. There are 37 registers. Are they divided between, how they are divided between general purpose register and the special purpose register? Special purpose registers. What do you mean by special? Visible, not visible? Whatever we studied in the material, whatever I talked about in my recordings about chapter 11, range, granularity, the overview, the general, general setup of the address. So you have to include it in your paper. Don't overdo it, but don't underdo it, and do it in your own words, answering these. Now, when we come here, look, I remind you, this is what I gave you. And I gave you one screenshot of ARM. You can use another screenshot, which makes you feel more comfortable with it, maybe less complicated. You understand it better. No problem. But you see this genius idea, 110, and then it goes to 3 bits here to tell the opcode. This is just to differentiate between whether the opcode belongs to a memory reference instruction or input and output, or it's a group of micro instructions. Genius idea at that time, guys. Genius idea. طبعا, of course, now they have more and more genius ideas. But can you figure things out? Doesn't have to be like you are doing a thesis in master's degree. The fundamentals of the instruction set of power machine or RISC computers. Are we okay now? Did I answer the questions? You don't have to get all information from one location. You just can answer many questions and collect the answers and put them in your paper and know what you are talking about. Are you okay, Levon? Because Levon asked the question. Levon?
I guess so, yeah.
Okay. If you have any other question, guys, remember at 12, you can tell me now we want to meet at 12, and then I will open, يعني I will stay in the session لأنه أنتوا اليوم بالسession at 12, and then we continue 1-on-1 or 2-on-1 or 3-on-1. It doesn't matter. طيب. You see, I took time to talk about this, and this is simply because I will be doing the same for the set of registers. Right. Chapter 12 is already opened. I will open this again, and if you can't see my screen or if I am not recording, please remind me as usual, please. So now if we, am I in the right place? Accumulator addressing registers? No, no, no. Bala. Wait. Yeah, okay. We talked about this. We talked about general purpose registers. Yes, and I gave you. Okay. Let me start from here. Then let me stay with this. I'm not gonna move around. So we are talking about registers. As a recap, we have 16 registers usually in sys computers, and some of them are visible to users, some of them are not. One. We talked about PC, and we talked about stack pointer as non-visible to the user. We talked about AX, BX, CX being visible to the register to the user, so we can directly say load AX, BX. Along with that, guys, I'm gonna have a data, which is the AC. I'm not going to see the AC in this example that I prepared. And then what do you mean by address register? There are registers only for address modes, guys. So yeah, for addressing. Let me show you this. Okay. This is a program I used to teach in Turbo Assembler. I changed it to RISC-V, as you know, and I said I will start it maybe next time if we finish today with this material. So all these semicolons are only explanation, guys. So they are comments. I don't need them if I took them off, but I just copy pasted from a previous program that I have in Turbo Assembler. Let me show you what I'm aiming to at this part. So this is like, guys, public static void main, blah, 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 in Java. Stack is you are reserving stack in memory. This is, remember, assembly language. This is the message. This is the data, guys. This is like you are saying string MSG equal hello world with an exclamation mark. This is similar to, this will come handy, guys, even when we study RISC, as if I'm doing assembly language now. I'm aiming toward many things in explaining this now. This is similar to When we talk about Java, string as capital letter, I taught you that. MSG is the variable name, equal, quotation, hello world, quotation, semicolon. What do we add to that in assembly? Comma 13, comma 10, comma dollar sign. I'm not going to waste my time explaining this, and it's explained here. I'm not going to even post this, and we are not using turbo assembler anymore. So just think of this as string message equal hello world. طيب هلا we come here. This is announcing the data part. This is announcing the code. This is assembly. This is how assembly works. Okay. Start. This is where the code starts. Code and starting the code. Move at data to AX. AX is the accumulator, guys. This is where we put data. AX is the accumulator in turbo assembler. At data, load the address of the data here. This, who knows what the data at is, guys? When the operating system with the help of the compiler, يعني the interpreter, يعني it has to choose the location to store the data in the memory. Even in contemporary computers, I told you, there is a place for the data, but it's not that obvious. When you say integer n or string a equal blah, 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 guys, this is a data area announced in contemporary computers without saying that this is the dot data. They will be stored somewhere in memory. Okay. Here, assembly is saying that take the address where you stored this data, the starting of the data. There could be here many variables, guys. Some of them are strings, some of them are integers, some of them are characters, arrays. So there could be more than one. But this is at data 0. This is the next one, if there is one. At data 2, at data 3, at data 4. Okay. Okay. The starting address, where did you store the first one? Take that address, suppose it's in location 1000, guys, in the memory, and put it in AX. And then take whatever in AX and put in DS. This is the address register, guys. This is an address register, and it is not visible. Users cannot update DS or read DS or write into DS. Only the system can use DS as data segment. It's the data segment where the data segment, the starting of the data segment, first location of the data segment in memory. Who decide where to put it? The operating system. And then it's the job of the operating system, along with the compiler and request of the compiler, to take that address that the operating system chose, put it in AX, the accumulator, and move AX into DS. Why couldn't say, why, someone might ask, why couldn't we say move DS, at data? Why this intermediate step, guys? This is a legitimate question and very good question. Because there is no direct connection to the DS from reference of registers. It has to go to the accumulator, and then from the accumulator to DS. Last time I drew an image slide where I said the answer will go to AC, and then AC will send it to the register, if you remember. We don't put the answer directly into the destination register. No, I drew an ALU with one register input and accumulator, add them, put the result in AC, and then move it to the register. Here, the same is happening. Accumulator is always like an intermediate point between CPU work and register set. I gave you example, guys, of this is data. dx is data, guys. And dx is address. ds is simply address. dx is a general purpose register where it can hold an address or data. In this case, look what is happening. Offset of message. This is true, guys. This is addressing mode. Offset of message. How far message is from the data segment address. There could be message 1, message 2. There could be more than one variable. So here it's saying point to message. Message happened to be at location 0 here. So no problem. It will be pointing to message here. Put that in dx. So dx is a general purpose register pointing to message. And then this specific to turbo assembler, TASM, turbo assembler assembly language, where it uses a function called 09H to print on the screen whatever a high is pointing to. Okay, I'm not going to dwell on this because we are not studying turbo assembler anymore. I use it as a simple example of turbo assembler, which is CISC computers. لأنه RISC-V is RISC computers. يعني it goes well with ARM processors. Do you have any questions on that, guys? Any questions on that? I wanted to notice here, and it will be mentioned in a minute, 09H, the high part, this is the function name, is put into the high part of AX. AX is divided into two parts. AX all in all, and then it's divided into A low and A high. Some instructions use A high only. Some instructions use A low only. And some instructions use the AX all in all. You see, this instruction here is using the A high only. This instruction is using the whole AX. This is the whole AX. I'm dwelling on this because this is what we are going to see here. I'm going to go directly to the instruction set here. A small, increasing flexibility. All this we have talked about it one way or another, guys. There are between 832 to 832 general purpose registers, more memory reference. We talked about all this. Remember the RISC we said about RISC? C programming, set of individual bits can be implicit, instruction decoding register, memory address register. I've been talking about this all the time. PC, called sometimes IP, instruction pointer, guys. Don't be surprised if someone says PC as program counter or IP as instruction pointer. They mean the same thing. And this is program status word. These are all the CC condition code that we can see. So for example, last time we saw what? And I explained it extensively. What was it called? The skip on zero. Skip on zero. Can anyone remind me, please, for those who reviewed the material? Skip on zero. What was skip on zero? What was it, guys? Anybody, please? Anyone? What was the instruction that I explained last time? We test and skip on zero, but it was not T. Anyways, ما حدا راح يحكي. and I don't remember the exact opcode for it, so I'm just gonna simulate that by referencing this again and talking about it. So there were something skip on 0, something skip on 0. So it was what? Test the AC. I explained this. I'm explaining this again. What's an AC? Test what's in AC. And then an answer comes back here, guys. Where will the answer go? It will go into this 0 flag. 0 flag. So answer of this actually will be stored somewhere. The testing, true or false. You know, in programming language, you say, مثلا, A equal check this and that. So A will carry the true and false. This is a great simulation of what's happening with this instruction. So it will test whether whether AC is equal to 0, and will put the result in the 0 flag. It will put مش 0 معناته 0. In the 0 flag, it will put 1 on 0 or 0. Now then, this instruction, guys, will test whatever is this in the flag. In this flag, it will test what's in this flag. So if it's 0, it will skip. So if there are 3 instructions, so this is this instruction, and then this is the next instruction, and this is the next instruction. If this happens to be 0, it will skip this one. It will not do it. If not, it will continue. So this is like a jump. So this is the 0. What is the carry, guys? The carry, if your answer is beyond, suppose you are using 32-bit register, and you multiplied مثلا 32-bit by 2. The whole full 32-bit, guys. Or by 4, or by 5, or by 7, or by 6. This will overflow. The answer will go beyond 32 bits. So this carry will be 1, which means that there is another register that's carrying the carry. Who's going to tell me where is the carry in von Neumann, guys? Where was the carry in von Neumann? ما كان في bit that says no. The carry will directly go somewhere. Where? In the MQ. So the answer will sit in A, C, and then the carry مش as a bit, the carry as the overflow, guys. هيدا الأوفرفلو will go into MQ. Interrupt, enable, disable. Did we talk about this, guys, as a condition code? Did we talk? Of course. If I'm running a program and I don't want interrupt to take place, we talked about this. We said disable interrupt. So what do? The CPU will have 1 bit. It becomes 1, for example. And this means the operating system, before granting the bus to any other process, it will check this bit. If this bit is 1, then we know what happened after that, context switching and blah, 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 blah. If it's 1, then no context switching, no nothing. The process will keep running until this change to 0. The programmer has nothing to do with this bit, guys. The programmer has nothing to do with this bit. The operating system will set this according to user request. In operating system, guys, we write programs that will ask for this interrupt, but it's never updated by itself. Now, any read-write instruction will ask for the CPU. CPU will check this, and the operating system already sets it up. Enable, disable. This one, supervisor mode or user mode, these are mostly in operating system, guys. Supervisor mode, it means now we are running even a program in the operating system. Or program system, what is it? It's a set of functions to do this and to do this. Rename, delete, update, open Microsoft Word. كله functions to do this and that. Interrupt handler, if you remember, it's a program. When you run one of those guys, you are running in the operating system mode. We call it supervisor mode. Most likely, when you are running there, guys, the operating system will say, okay, I don't want anybody to interrupt me when I'm doing something. Then I set this condition code for interrupt enable disable as disable interrupt. The rest are the same, equal, guys. بدل ما هيدي skip on 0, skip on equal, who is going to give me an instruction in Java that will use this one, guys, on strings, مش on integers. يلا. I'm gonna wait here عن جد for 30 seconds until you collect your information, and when this will be set 1 or 0, when you are executing a Java instruction on strings. I have a chat. Okay, chat at, no, I don't see a chat. Ambala, I see it saying something about character. Char at, is this an instruction in Java? Hek char at, char at as char, capital letter at. No, this will not set the equal, no. This will set a result as an integer somewhere in one of the registers. But thank you for answering. Anybody else? Char at, if you remember, it was مثلا A equal char at, this is stupid writing, but يلا, and I, for example. I have an answer now. Char at I, this will bring a value here. It's not 1 or 0. Let me see the chat. Dot equals, thank you very much. Yeah, dot equals, yes. Thank you, Lana. It was good answer. Let me chat it here, but let me write it here, but in text format. Here. What do we say? If str1 dot equals str2. I think this is the right syntax. This will be translated, guys, into many statements in assembly language. Store str1 maybe in the AC. Store str2 in another register that is available to accumulator. I drew them last time. And then test them. This is easy for the ALU. And then what happens, guys? I like this. Let me draw it again. Oh, wait a minute. So I'm here again. And where is the pen? Where is the pen? And here, this statement now, guys, I'm executing this statement on the ALU. This is the AC. And this is, let's call it MQ, guys. Hey, مثل Von Neumann. MQ. And طبعا هون set of registers ما خصني فيهم. Okay. طيب. If these were already here, then we have to move them here, guys. If str1 in one of the registers, we cannot use it from here. We have to move it here لأنه AC works on only, sorry, ALU works on 2 registers specific register, guys. So even str1 and str2 was loaded into registers, they have to be brought here. This is not my talk now. My talk is the result. So AC has STR1 value one way or another. MQ has STR value one way or another. Now this is the logical test, guys. Logical. ما هو arithmetic and logic execution. It test. The result will not go to AC. Like when we were adding, guys. Where will it go? Where will it go? It will go into this equal bit. It will go into this equal bit. It will not go to AC. It will go into this equal bit, guys. These are a word مسميها PSW, program status word, with bits here. And after that, the CPU, I mean the instructions within the CPU, will go to that equal bit. Equal bit. Load it into AC. بتقول شو هالحكي هيدا يا عمي؟ شو عم نلعب نحن؟ مش عم نلعب. This is how it works. We'll load it here and test it. And the outcome of this will happen according to that. The skip will happen or not happen. مش ضروري تكون skip on zero, guys. Jump on zero. You will see this in all assembly language. In every instruction set, you see jump on zero. Jump equal. Jump negative. Jump positive. كلهم موجودين. Okay. Let me stop this and let me go. خلاص حكينا كثير عن condition code. Okay, here. This is the what? Let me clear it. Let me clear the screen. Come on. Clear screen. This is, guys, the 286 computers, 386 computer, and 486. 386 computers and 486 computer are very similar, guys. Very similar. These are the general registers, guys, available to sys computers, Pentium specifically. Most all other, يعني حتى الموتورولا وهيك, they are almost the same. هذا الموتورولا ليك MC68000, almost the same set of registers. They are used differently. Motorola does not have this. We don't have that for this one. Maybe they divided it later on, guys. But AX in 286 was put into larger size, and it's called EAX. EAX. Extended AX. And then this is where we have the A high and A low, guys. A high and A low. So AX will be divided into heck. So this is 8 bits, for example, and this is 8 bits in the 16-bit register, guys. In the 32-bit register, they will be divided into 16 and 16. Turbo assembler, the one that we run, guys, it takes a byte from here and use it, and this is enough for it. And it takes a byte from here, A high and A low, and then it takes both of them at some times and use them. Okay. In here, you see that it's only one slide, مش هيك? What did I do? I went into, not this one. Where am I now? Where am I now? Yeah, here, yes. أول شيء, I put the source of information. So this information come from this source, www.eguide.com. You can go to any other location and study more. and pick up more information. Look, it's the same setup, guys. Here they are. طيب هلا رجعنا لقصة big Indian, small Indian, whether from left to right or right to left, it doesn't matter. This is the PC, guys. Program counter, instruction pointer, it's the same. It can be used in 16 or 32-bit. This is common, guys, to both 386 and 486. يعني whether you have 32-bit computer or 64-bit computer, it's the same setup of registers, guys. مع one difference I showed it to you at the end of the handout. Why this and why this? Okay, if my program is small, you remember the dot model هلا فرجيتك عليه بعد هون. Look, see this dot model? This decide whether my program is very large or small or medium. انت ما تحطها هاي، انت ما بتحطها هاي anymore. هو بيخلقها when the compiler compile into machine code, it will tell whether this is a large program. الكompiler بيمشي وراهم. It parses everything in the program. So if this program is using small number of instruction, يعني 0 to this is قديش 16 to the power 16، يعني شو 4K program, fine. If you go for more 4 giga, خد روح take the whole EIP. DS, who's gonna remind me for this, guys? DS. A minute ago I said the data segment. The data segment where my data starts. What is this CS? What is this SS? What is this FS? What is this GS? Do I want you to memorize all these? No, but you have to have an idea about them. Now, this is the extended one. مش هيك؟ فإذا هول الصغار هول الكبار. طيب. Stack pointer. These are general purpose register, guys. AX, BX, CX, DX, or this is stack index. كمان 16 and 32-bit. This is the set of registers and they are being explained. You see? Look, stack segment, general purpose registers, DI, what do they do? Segment registers, what do I do? Look at this. Accumulator, هيدا وهيدا, description, description, control registers. These are the control registers, guys. This is also explained. Debugging registers, test registers, system registers, flag registers. These are the flag registers. This is zero flag, guys. This is the zero flag that we were talking about. Interrupt flag. ليك شو هيدا؟ enable disable صح ولا لا؟ This is the set of condition codes that I was talking about a minute ago. Continue. Look, virtual memory. Okay. Now, it is your job, guys, as a student. We instructors, we introduce you to what is the meaning of this and what's the importance of this. This set of registers is how a machine language work. شفنا الانستراكشن set, guys. Add و subtract و multiply و delete. طب on which set of register it works? How registers work? For us, we introduce samples. We introduce examples. For you, you have to go and a high or a low I mentioned, go through them and understand what they do. And afterwards, when you submit this assignment on instruction set, this is the code that I'm clicking on. And these are the register sets that we will see in RISC computers, guys. So look, they differ, مش هيك? They are registers after all, but how do we use them? How do you use them? Look, who is going to answer this question? AX, BX, CX, DX in CISC computers, in Pentium, and in Motorola السيسك لأنه موتورولا كمان عنده power computers. They are translating into from R0 to R12. Why 4 registers become 13 registers from R0 to R12? 4 registers AX, BX, CX, DX. They play the role of 13 registers in RISC computers. ليش? Who's gonna? I explained this already. Why, guys? Chat with me or answer me verbally, please. I've mentioned this many, many times. Anyone? You can chat, guys, if you want. You see, even we are online, should be able to involve yourself in answering this. ويخيلوا كان غلط حتى بالصف نحن it's on recording, so I will not do take my sessions as assessment, guys. No way of assessment. If we cannot do in-person exam, I'm not gonna do online exam. I'm gonna go with you one-on-one at your time when it's best for you. Maybe half an hour. I ask you question and I give you a grade. احنا good, we have 1 grade, guys. I'm thinking also I might join second exam with the final and see what happens between now and then, but this is different story. I gave you the chance to think about my okay, close. Okay. AX, BX, DX in, where are they? Where are they? Hey, AX, BX, CX, DX in 286 computers. EAX, EBX, ECX, EDX are the extended in 32-bit computers and 64-bit computers. 4. Why here they are 13? بتقول لي why مين قال انه they are 13? Obviously they are not general purpose. بعدين بيجي stack pointer وغيره والPC 1. It's because the main idea of RISC, I keep repeating in every recording I do. RISC computers say easy instructions, and the only instruction that use memory are the load and store. ما في add register to memory. ما في subtract memory from memory. These are CISC computers, guys. Instruction set. In RISC, load from memory, store to memory, and that's it. So when we are reading from memory and storing into a register, we don't want that register to be replaced very fast. ليه؟ لأنه I might be using it again in my program. So if I have value n, for example, my program, integer n equal 5 يا أخي, I bring n into R0, and then if there is m, I put it in R1. If there is x, I put it in R2. If there is array of I put it here. Array of 2, I put it here. This, I put it there. Yalla, 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 yalla. If I happen to have more than 13 variables in my program, then I start kicking them out to the RAM by using the store. مش انت you store it. Then it's the job, but you have to store it back yourself. Yeah. And also the operating system has to do something with that also, guys. It's different. We explain this more in operating systems. But why 13? Why are 0? They did a study, thoroughly study. You can look at it on the internet and say how RISC people defend themselves. why they chose مثلا 13 or less or more registers. ليش مش 15? They made a study and they said most most programs have something between 5, 6. Sometimes we write program with 3, 4 variables, guys. خلاص بكفي. So, coming back to the point, these registers, guys, different between user mode. كلهم user mode. طيب, we have seen the supervisor mode in CISC. This should be eye-catching. Why don't you say, does ARM register set has a supervisor mode instructions? Then it says here user mode. You have to ask the questions similar to what I have explained in my lecture. Whatever we did on register set of Pentium, I want you to do on this one. Look, it's there, look. And there is an explanation and explaining. Look, but I want you to understand more and study more on that and explain to yourself. I will pick up common ideas that came into your papers, these 2 papers, and I'll put them on my exam, whether verbal exam or in-person exam, guys. ما في online exam. If I ask you questions like I'm asking you now during the assessment and you don't answer, it means you don't know. I will not give you enough time to go and chat GPT. ما في. يا اما you know يا اما you don't know. إذا بتقول لي I forgot مثل ما أنا sometimes forgot, I'm not under test, guys. ما حدا testing me. If you want to test me, I go and memorize them and I answer all your questions. But you are being put under test. And then, if you tell me, Wallah, I forgot that 1 time out of 5 times, you get a 90. أنا I forget. بس مش كله I forget, I know but I forget. وحياة الله امبارح راجعت وأنا I forget. مش هيك. طيب, having said that. طيب, now, where do we go from here? Where am I أصلا? I'm here. Okay? We continue from here. Data flow, fetch instruction. We have been talking about it for a long time, guys, from the beginning of this semester. Let's look at the points here. You did this in your assignment when we simulated Von Neumann machine. شو حطيت بالفتش دخلك أنت؟ Move PC to MAR. Read memory location at MAR. Put it in MBR. يسلموا ديتك. مش هيك ولا لا؟ Guys, let me remind you what you should have done in what? In that assignment. No, maybe I want this one. In your assignment, guys, when we did, unless you didn't do it, some of you didn't do it, هن حرين يعني الماتيريال تلحق بعضها. I am doing the fetch in that assignment, guys. Look what I do. If opcode is equal to show fetch. No. If fetch operation initialized by what, guys? The fetch initialized by the operating system executing your with the help of the compiler executing your program. If fetch AR equal to PC. Is this correct, guys? Yes. لأنه PC was already set. We know that PC, and I remind you it's called IP also. PC is set before you finish executing the previous instruction. So this is legitimate. And then what, guys? MBR equal memory at MAR. That's it. This is the fact. One more. Who is going to tell me what did you write here in your program? ما تقول لي نسيت صار له شهر. اللي بيعمل program ما بينسى بشهر. What else is in your fetch instruction, guys? بعد شي شغلة وحدة. Come on.
PC equal PC plus 1.
Yes, thank you. لأن اليوم عم جاوب كل الأجوبة. That's it. That's it, guys. طبعا. If you want to continue in the fetch and say divide into IBR and انت حر. يعني انا اعمل لك هيدا الاساس. شو هيدا الاساس؟ لانه مش كل كمبيوترز مثل فان نيومان عنده 40 bits مقسومين ل 20 by 20. So this is general. خلص, let me see this now. Compare this with this. Let me compare this with this now. Fetch PC contains address of next instruction. ما بنشتغل فيها ابدا. ما already there. Address move to MAR. Look, PC put in MAR. Address placed on address bus. طبعا هيدي specific مش هيك طبعا. Control unit request memory read. Look, هيدي اثنيناتهم هول اثنين in theory. عفوا. Let me close this. Let me go back to this so I don't write every time. Okay. So both of these guys here. Results placed in data bus copied to MBR, then to IR. Look. IR is not von Neumann specific, guys. IBR is von Neumann specific. But every MBR divides itself into IR and MAR. Yani if you want to include them here, you can add also. Tell us, you can include them here. You can add here MBR first, مثلا 5 bits. Suppose that MBR. First 5 bits go to IR, and the rest will go to MAR. Legitimate. In every computer now it is. هلا I said 5 bits. The opcode might be 10 bits. يمكن يكون عندك 1024 up to 1024 opcode. BDP8, guys. How many bits will be wasted? No, will be put into IR, guys. BDP8. How many bits will go into IR? Yalla. I want an answer, please. How many bits will be put into the IR if we are continuing with this? 3 bits. لأنه it all starts with 000 up to what happened? I clicked something by error. 000 up to 111. All of them are like that. This is where it starts. This is where we start the control unit here. It says IR, بعدين شو the opcode, the logic circuit or the control unit will analyze what the 3 bits are. So it looks into this. If they are between this and 101, I said مش هيك, then it's a memory reference, blah blah blah. When it moves to 110, then it's an input and output. And what? It goes and it reads. These are not coming into the control unit, guys, from the opcode. No. These are instruction bits that will go to be again put into IR to know what are they, which input output. But it's not an opcode by itself. It's an opcode sub opcode from this opcode اللي هو 110. وبعدين عندنا ال 111 و 01. You remember? And we counted those. Okay. I like this design very much, guys. It's very simple, very straightforward. I'm going to ask you something like this in the exam for sure. Meanwhile, PC incremented by 1. Here we are. Okay, let me close this and let me go down. Let me see if it's IR is examined. Of course. هلا بنيجي لقصة direct و indirect, guys. Blah blah blah. Okay. This is something important. هلا we have seen something like this before, but let's مش before. هلا شو هلا I want to close. I want to clear it أول. Okay, clear all drawings. Okay, guys, this is the fetch instruction that happens a minute ago. Can we number the lines that will be active inside the CPU during the fetch? We drew it into مثلا PC put in MAR يعني like program. Now this is exactly how it executes. This is the flow of the data within the CPU. Can you number the lines? I will number the first line, guys. هيدا PC is put into MAR. هيدا هو نمبر 1. هيدا بيشتغل اول واحد بالفتش انستراكشن جايز. اول شيء بيشتغل البي سي to MAR. بعدين مين جايز؟ MAR to the bus. This is 2. وشو بعد 2 جايز؟ بالتو اثنيناتهم سوا شو بعد؟ مين بعد رقمه 2 جايز؟ مين بعد رقمه 2؟ قلنا we put PC into MAR. بعدين MAR is put in the bus and the control unit asks the memory from this address to give us back results. So this is 2 also. They go together, guys. وهو بس وعم يشتغل يعني هيدا الباص داتا وهيدا الباص كنترول شو خصهم ببعض. Now what is 3 guys? 3 مين 3؟ memory answer back مش هيك؟ لأن we are fetching يعني we are reading, so this will work next. 3 what else is 3 guys?
على الMBR.
Thank you. 3 and then what? Obviously 4. What is this, guys? What is this? What is this? كان بعد في شغلة واحدة وانت قلتيها لنا. What was the last thing I put into this instruction? do PC++, مش هيك? So the control unit will tell the PC to add 1 to itself. So this is 5. It might not be 5 guys, لأنه it might be 0. You might increment the PC قبل شو بعرفني. بس usually it's the last step. Is it clear how CPU works inside? This is how it executes instruction, guys. It's just signals going from here and there to do something here and there. Control unit send PC some bits. هيك هيدا وقت اللي بيكون هيك يعني هيدا multiple bits, guys, multiple bits. One of the bits here will tell the PC to increment itself. Another set of bits, guys, will tell the PC مثلا to transfer to register 3 and so on and so forth. This is the heart of the program that you wrote in Von Neumann. I wanted this to happen at the beginning of the semester for you to understand شو يعني control unit. شو يعني control unit. This is not Von Neumann, guys. This is not Von Neumann. This is contemporary computers. كلهم بيشتغلوا نفس الطريقة. Okay, let me stop this and go down. Let me clear the screen. لأنه بدنا نرقم شيء جديد. Clear all drawings. يلا. Indirect diagram, guys. يلا. Indirect. لقينا شو اسمه الكنترول يونت so that there is an indirect reference to memory. اسمع شفناها بالادريسنج مود guys. let me see لا مش هاي. let me see وين التهيئة text. I'm executing this statement guys. load indirect m of 20. يلا هاي. how does it execute here? number the lines please for me. عملوا معروف. number the lines for me. I'm executing this instruction. I'm not fetching, I already fetched. Load I in the control unit. It could be guys 0 1 1 0 1 1 2 4 6 يا 6 bits of code. ليش لا 6 bits of code. هيدي هي هون. هلا شو بيصير من وراها؟ يلا هاي is already هون وال20 وين موجودة؟ مين بده يقول لي 20 وين موجودة؟ answer this question at least.
معيار.
thank you very much my friend. هلا ليه مش عم تحكي كل الوقت؟ انا ما حابب، انا بعرف انك بتعرف كل الاجوبة اجمالا ان شاء الله، بس ما عم تحكي بالمرة يا ما مش عم تساعدني. and بالام اي ار في عندي 20. okay so here it is. none of these lines are activated so far. هذا الرسمات هول موجودين already. يعني انا فيني محي هول and you can say that look ليك شو رح ساوي؟ clear all drawings. رح اكتب هون 0 1 1 1 0. حرام محيت الانستركشن وهون في 20. this is what guys, this is load indirect. رح اكتبها بايدي. يلا فكروا اذا بتريدوا. load indirect. يلا شو بده يصير؟ مين اول لاين؟ رقموا لي اللاينز. كمان ما حدا؟ اوكي. what did we do a minute ago guys to execute؟ مش قلنا الام اي ار اول شيء بنحط على الادرس to execute. بدي شيء من الميموري. هلا a minute ago when we fetch an instruction and when we fetch data guys مش نفس الشيء. listen to me, if you don't know that they are the same, they are the same. whether you are fetching data or you are fetching instruction it's the same. شو بتفرق معه السي بي يو؟ السي بي يو بيجيب مجموعه بيتس وبحطهم بالام بي ار بعدين انت شو بتساوي معهم؟ هو ما بعرف. so this is one for sure. what else guys؟ the opcode مش هيك؟ the opcode this one, the opcode this is one كمان. we are fetching from memory location 20 هون. now what 2 مش هيك؟ 2 هلا سويناها. ما هو فاتشنج غير اللودنج هي فاتشنج وحياتك. 2 2 هلا مين بده يقول لي what's in MBR guys؟ what is in MBR؟ this is load indirect. in 20 suppose this is the memory extended. ليك رح يخلص الوقت منيح انتبه. هون 20 guys هيدي 20 suppose وفي بقلبها هيدي 20 مش 30 مبينه مثل 30 20 وفي بقلبها هيدا الادرس 5000. في بقلبها هيدا الرقم. I gave away the answer guys. this 5000 for indirect addressing the address that we studied this in the address mode where the number is at guys. if this memory extends up to 5000 and this is the 5000 and it has in it -3, then what will happen? MBR will have 5000 in it. it moves where هيدي 3 it moves into MBR. شو في هون هلا 5000 صح ولا لا؟ now what the 5000 will go again to the memory. مش قلنا نحن بالindirect to memory accesses? This is what we mean. Then this will go again into the memory. We'll get whatever in 5000 and put it in NBR. شو صار هون في minus 3. sorry بس غلط. minus 3. وبعد في step وحدة guys. شو هي؟ هون بيكون في البي سي سوري الاي سي. and as a conclusion الام بي ار بده يبعتهم لوين؟ للبي سي. This is it. Is it better? Is it clear? I don't know. I am taking lots of time on this, guys, because you know what you get out of this course is this material عن جد. Instruction set and register set of a computer. Instruction set of the processor and the register set of the processor. From there on عندي I/O module, عندي context switching, عندي شو اسمها هيدي cycle stealing. بيصيروا مهمين وبيجوا بالانترفيو when you are asking for a job, guys, being interviewed. بيسألوك هيك أسئلة. Check it on the internet if I'm right or wrong. Let me stop recording.